Now that we know that we can treat units algebraically, let's see if we can use that knowledge to figure out what the units of a variable might be from some formula. So let's say that I'm given this formula that capital K is equal to lowercase b over s squared. And let's say that we are also told that b is going to be in centimeters, and s is going to be in grams per centimeter. So that's the units of s is grams per centimeter, b is in centimeters. What are the units, or what is the unit of k, or the units of k going to be? And I encourage you to pause this video and think about this. Well, let's try it out with just some value and some values for b and s and see what happens. Let's say that b is equal to 1 centimeter. And I'm just using 1 because it makes the math really easy. And let's say that s is 1 gram per centimeter. So we know that k is going to be equal to 1 centimeter, that's b, over 1 gram per centimeter squared. 1 gram per centimeter squared. Now, we've already talked about the idea that we should treat our units like algebraic quantities. So this should be equal to 1 centimeter over. Now, you could treat this as 1 squared times, and let me rewrite this. You could rewrite this as 1 squared times grams per centimeter squared. And this just comes out of the idea that if I have a times b to some power, say the second power, that's equal to a squared, b squared. And we also know that if I have a over b to some power, say squared, that's the same thing as a squared over b squared. So I could rewrite this as this is going to be equal to 1 centimeter over 1 squared is just 1 gram squared per centimeter squared. Now, what is this going to be equal to? Let me write it over here. Well, that's going to be 1 centimeter in our numerator. 1 centimeter. Let me do it in that green color so you can keep track of things. 1 centimeter from our numerator. Instead of dividing it by 1 gram squared per centimeter squared, I can multiply it times the reciprocal of this. So times 1 over 1, which is just going to be 1. But let me just write it that way just so that you get that I'm taking the reciprocal of 1. So 1 over 1 times the reciprocal of gram squared per centimeter squared. Well, that's just going to be centimeters squared per grams squared. So what's this going to be equal to? Well, I have 1 times 1. So if I take the numeric parts, 1 times 1 is just going to be 1. And now, remember, we can treat the units algebraically. I have a centimeters times centimeters squared. Well, that's going to get me to centimeters cubed. Centimeters to the third power. And that's not, this isn't c times m to the third power. This is centimeters to the third power. You could write it like this if you wanted to be clear about it. Per, and over here we still have grams squared. Per grams squared. So the units, I just picked the numbers 1 arbitrarily. So the 1 isn't what matters here. I just picked those numbers. What matters here is what are the units? What are the units for this formula when b is in centimeters and s is in grams per centimeters? We see that k is going to be expressed in terms of cubic centimeters per gram squared. And I can't tell you offhand kind of an intuitive physical representation of that, but you at least know the units. You have cubic centimeters, which you can kind of view as a volume, divided by, I guess, a mass squared. And a mass squared is a little bit less intuitive for me. But at least we know what the units of k would be in this formula, given the units of b and s.